All right, well done. So we've spent some time solving equations, we've spent some time solving formulas, and now in part 4, what we're going to be doing is solving inequalities. And the good news is when we're solving an inequality, the golden rule that I've taught you up above basically applies. So you can do whatever you want to both sides of the equation and still be okay. But there's one exception. All right, and that's basically when you multiply or if you divide by a negative number, right? When you do this, you have to flip your inequality. Otherwise, everything the same, all right? So that's the good news here. So we're gonna keep on doing what we've been doing, all right? And then just taking if I ever in my work multiply or divide by a negative, we gotta take the inequality and we gotta flip it around. So let me rewrite the inequality over here. So we have negative 2/3 x is greater than 4, all right? And let me change colors here real quick because what I'm going to choose to do, the golden rule I'm going to play is I'm going to multiply both sides by negative 3/2. And in so doing that, right, we're going to have to flip the sign. So let me go back and write the work here, all right? We have negative 2/3 x on this side and positive 4 on this side. So I essentially have the same inequality. I multiplied both sides by a negative, in this case, negative 3/2. So that causes me to flip the sign right there. If we'd have multiplied both sides by a positive 3/2, we'd have left the sign alone, all right? So again, that idea, that exception, that we usually flip the signs, right, if we basically divide by a negative. All righty, so what's gonna happen when we do that? Right, while doing some math, right, over on this side, a negative times a negative is a positive. Negative 3 will cancel out with the negative through there. 2 will divide out with the 2 there. So we're just left with x. And that is going to be less than, well, over here, if we write 4 is over 1, right, 2 goes in itself once, goes in there twice, and we have basically negative 6. So there is our answer, all right, for this inequality. X will be less than negative 6. All right, but I want you to go deeper and write your final answer in interval notation. So to see the interval, perhaps what's best to do is to actually graph this solution set. So let's go to our number line, right? Somewhere on this number line is 0. Somewhere on this number line is negative 6. And because because our inequality right here is a strict one, that means we actually have an open circle at negative 6. Negative 6 is serving as a boundary, but we're not allowed to be equal to it. And our x's are less than or to the left of negative 6. So we're basically going to color our number line in this direction and put a big arrow saying it's going to go on forever. So my solution set actually has two forms right now, an inequality and basically a graph. So what about the interval notation? Well, the interval notation, all interval notation starts with something that bounds me to the left, comma, something that bounds me to the right, and then we're either using parentheses or we're using closed brackets depending on if we're allowed to be equal, all right, to the left and right bound. So looking at my interval here, right, it's basically going on forever towards negative infinity as I go left. So there's my left bound. And then we're bounded to the right, right? All my values are bounded by negative 6 to the right. We're not allowed to be equal to negative 6, so I'm going to use parentheses. And we're not allowed to be equal to negative infinity because nobody knows how to get there, all right? And so for that reason, there would be our final answer for this problem, right? Our solution set is the interval from negative infinity to negative 6. But you'll notice from the work that I've shown, when we're solving an inequality like we are, we actually have 3 different ways. As a matter of fact, there's actually 4 different ways if you can consider set builder rotation, which I'll do. But the big one, all right, are the 3 that I'm showing you. We either have a final answer as an inequality, as a graph on the number line, or interval notation. The set builder notation, I should probably prepare you that just in case somebody does show you that. You always start off with a curly bracket that describes the set. We're talking about x values, and then this little up and down line means such that. So all x, such that, and then you have to give it a little property, and we're going to close the parentheses there. So we're talking about a set. What's the property? Well, we just basically mimic the the inequality we had in the first place. So we basically have an inequality way of writing our answer, a graphical way of writing our answer, the interval notation way of writing our answer, and then what's considered the set builder way of writing our answer. And that, in a nutshell, is how you solve inequalities. Use the same golden rule, keep doing the same thing to both sides of the equation, right? And then the only exception is as you do that golden rule, if anywhere in your work you find yourself multiplying and dividing by a negative, you got to flip the sign like I did right there in my work. All right, so that should wrap up all the stuff you probably need to know, from R2, all right? And so there's a homework set there if you want to practice later on in this module, and I'll be showing you in the next video some things that are going on in R3. Thank you for your time. Thank you for your effort, right? Let me know if you have questions in class or via videos. Talk to you guys soon.